So welcome everybody to our session, and this is the first session back on the office hours sessions that we have again, and I'm so happy to be here. And welcome Daniel, that's my co-host today.
Hello, everybody. It's a pleasure to be here.
Yeah, and the idea is that we are going to talk about Timescaledb for TypeScript developers, and that will be a bit of live coding too. Daniel is developing a bunch of TypeScript packages for Timescale. He worked as a freelancer for us. And basically, I was the guy that built the Ruby package, and I was advocating like, hey, we should definitely have a TypeScript package. And then Daniel worked on the first prototype. And today is our first webinar to also share about it and how it works. So to install it, it's simple as npm install. We already have the first release done, and that's the main topic of our session, but we will also cover the other packages, and especially we'll give you some background about how timescaledb works, especially for you as a TypeScript developer, right? So this will be a kind of introduction to the features that timescaledb offers, and then Daniel will show you the API, the interfaces, and the inner hooks behind the frameworks that we use to build the packages. My name is Jonatas. I am a developer advocate here at Timescale, and I am also community manager here. So I work at Timescale for 40 years now, and I'm very excited about Postgres in general. So I really believe in Postgres for everything. And this is so great that we start covering more ecosystem now. So part of my initiatives here is like we expand the ecosystem and make it more developer friendly to meet developers where they are. So several times we love SQL, but we want to just write in our personal and favorite languages, right? And Daniel, if you want to introduce yourself.
Yeah, thanks, Jonatas. Hello, everybody. I'm Daniel, or Dan, and I do open source engineering. You can find out about our work at rconnect, R for Rocket, connect.tech, and you'll find me on GitHub or conferences working on things like drivers that I have done with Jonatas, or APIs or AI agents. And you can reach out to me on Twitter or on LinkedIn just by Dan Starns.
Thank you. So we also have the Timescaledb community. That's part of my part-time job. So I work in the community as a community manager, and I try to help to build the community, to grow it. And we have always, let's say, great conversations in our community. So if you want to join us, we have a TypeScript channel there. So you can also interact with us on Slack, and also we also have a forum if you prefer more async, or even Slack is async, but it's also a great way to communicate and talk with other users. So there's like around 12,000 people. So this is a big community that we have there. If you are not very familiar with the Timescaledb, we have more than 3 million open source database active in the world. And this is also a great way that you just expect that this is a reliable extension. So we have folks from NASA, from JPL, or from CERN, from Toyota, and all types of companies using us, the open source version or the cloud version. So this is a bit of Timescale, and the community is really great. It's focused on the open source side. So if you want to join us, you will be very welcome. We have Timescale Cloud channel and other channels about more deep conversations. So we also have channels to talk about industries. If you are like on, let's say, financial market data, or if you are on a specific industry, you may find other folks that are sharing the same challenges. So let's start this walkthrough. So just a heads up of what timescaledb works. If you want to see the official GitHub repository, it's without the -ts. So just timescaledb is the repo that belongs to the main extension. Timescale is the name of the company, and timescaledb-ts is the name of this repo that we are going to talk today. This repo contains the implementation of all the connectors for different, let's say, packages. So we have a connection for type RM that's different from other, let's say, RM connections there. So they are all together. So to do the setup, it's a very easy change that we are going to do. Daniel will show it in real time, and I'm going to just walk through the changes here to introduce you with the concepts, and then later we can walk through the internals of both sides. So the first thing that is the main component from Timescale is hypertables. So hypertable is what we call the architecture that makes the partition automatically for your data. This is kind of doing this partition based on the time dimension. So when you have table, in this case, our table name is page load. So we are talking about just like tracking page loads, how much time it takes to load some page. And we are going to just transform this data into partition data. Why we are going to do that? Because when Postgres reaches like 100 million rows in a single table, things really get a different performance path. So you not get the same performance after this workload. And with TimescaledB, you can just enable this extension and transform your table into a hypertable. And doing this, it will partition your data by your time column. In this case, the name of the column is time. And we are going to just use this notation to say, hey, here is the time column and this is the hypertable. You can also set details on this hypertable. You can put some configurations that we are going to cover a bit later. So in the migrations we are now talking about TypeRM specifically. We don't have too much changes here because we are just mixing the notations that we have in the model with the migrations here. So I guess Daniel can share a bit more details how it works.
TypeRM is based off of, it's an ORM and you define your types in your code and then your migrations are derived from those types. So with our timescale wrapper for TypeORM, we're just hooking to the generation of that migration. So from a user's perspective, you don't really have to modify the migrations at all. You just add these constructs to your models that Jonatas, you highlighted in a previous slide, like hypertable or time column, and then the library is going to automatically find these at migration, and then it's going to apply the necessary stuff. I think the benefit of TimescaledB is that it's just an extension of Postgres. So we're really able to kind of hook into all of the existing tools here and just add the timescale specifics when and where we need them.
Thank you. Let's just go into more details of the hypertable options and what you can do there. So think that when you start creating a table, you can say, for example, the chunk time interval. In this case, we are not introducing this, but chunk time interval by default is 7 days. So when you use the create hypertable, it will automatically split it in a new table or a new partition of your big table every X days. So in this case, as we are not passing this parameter, it's every 7 days. So a new table is created every 7 days. And then when you querying the table, let's say, for example, you are checking page loads from the last month, and then you have one table per week, it will just use the last 4 tables. So it will use the last 4 partitions instead of using all the hundreds of millions of rows that you have around. And that is the core thing that makes it really fast. So this is the chunk exclusion that happens when you put a where clause that involves your time column, right? So if this is the same dimension, it's smart enough to just say, hey, I don't need all those tables. And every table also contains its own indices and its own constraints. So instead of having like a constraint across all the chunks, you have one constraint per partition. When your data gets a bit older, we say that it's coding down, right? So you are not using that data from 3 months ago. You still want to keep it around so you can compress it. For example, here we have this compression and you say, hey, compress my data and compress it after 7 days. So you are just making this a policy. So there is a background job that says, hey, let's see what are the chunks that the red has all data with 7 days. And then you can compress it. And then it will save you like 95% space if you just adopt something like that. So this is very interesting. And you can now configure the segmentation of your compression. So compression will basically transform your data from like raw data into, let's say, columnar storage. So you have a row-based storage, and then you go into columnar mode, and then you start aggregating. So in this case, it will aggregate data by segmenting by the user agent. So it means who is the person or something. So you can use this segmentation to have a better, let's say, series. So your series is all correlated because they belong to the same user or to the same device or user agent in this case, right? So in this case, for example, we also created this idea of a composite primary key with the user agent. So several times you need to find a way to say, hey, I need to have a primary key. And on hypertables, this is not a good idea to have like a unique ID across all the chunks. So you combine always time with something. So you don't want duplicates of your same user agent over the same time. So you can also use this composite primary key. Is everything right, Daniel? Anything that I missed from this slide?
No, I think you depict it well. When I first started learning about timescale when building this driver, I got my head around timescale more by what you said, which was about background jobs. So essentially you're like defining a bunch of background jobs in your Postgres instance that like splits up the data and like compresses it and just keeps things very optimized. I was wondering, as you were speaking about that, Jonatas, in terms of the interval, do you have an example of like a data set that would be a very short, like a very brief interval versus like a very long spaced out interval? Like we would put like, say, 30 days on this hypertable. What would kind of the table look like? What would the data set look like for that?
That's a great question. It's all about the workload balance that you have. So generally, we have the 25% rule that we say, for example, if you have 8 gigs of RAM, use 25% for the chunk size. So your chunk should be around 2 gigs, and then you can just try to fit your data. So it depends on the data density. Sometimes you collect a few per minute or a few per hour. The thing is, when you compress the data, if you have a 2 gigs chunk, you may got like a 200 megabytes or 100 megabytes if after compression, right? So it will become much smaller. And the schedule interval will make you compress, let's say, more often or less often. This compression is also responsible for a few tasks related to compression. So, for example, you can backfill data on a compressed data and need to just create this compressed chunk that will contain some dirty compression, compress the data that needs to be marked to be recompressed. So if you still have some backfill going on, it would be better that you have like a shorter intervals. Then you also fix these recompression things that you need. And also it depends on how long it takes to compress a chunk, right? If your chunk takes too long, then it may be a problem. A reminder is that like all the data from the chunk should be older than this, let's say, compression, right? So if you compress after 7 days, you have also to consider that all the data will have 7 days. So it means that the last data of your chunk will have 7 days. Generally, it will be like, let's say, 15 days to get your chunk compressed then, right? Just a small detail. Sometimes people just to await that a segment of their chunk will be compressed, but it means all the data. And then and also another interesting thing is that as we expect that the data is cold, the background job just tries to compress the entire chunk at once, and it doesn't lock it, and then it just swaps and replaces. It checks, hey, nobody changed it. I have a compressed version here, so it just swaps the reference of the table, and it's a very fast operation. So it's quite interesting. And a downside of using compression is that you can just hit, let's say, a larger volume of data that you never had before in the same hard disk. So sometimes you struggle if you have a migration that you need to decompress everything, because this will be hard if you don't have the same size disk size.
So it seems like an art form, really, in terms of like tweaking the amount of time in when you need to compress. I'm sure that the 7 days default is reasonable enough to just get started.
Yeah. Also, just we have a big table that we are like dog fooding. So, for example, in this table, we were getting 800 billion rows a few months ago. Now we get 1 trillion rows per day. So this is a huge, almost 2 petabytes instance. And then in this case, our actual, let's say, chunk time interval is 10 minutes. So every 10 minutes, we have a new partition because we need to keep compressing and making this pipeline go. So that's also thing that you can think when you get like a very large scale. But this is like an insane scale.
Yeah.
Yeah. Okay. So wanted to cover the continuous aggregates, Daniel.
Let's do it. Yeah. So, if we circle back round to background jobs, which is kind of like how I like to think about using timescale, there might be a chunk of data that you always look at. So in our examples in these slides, we're talking about page loads. So you can imagine you might have like a dashboard that might show you kind of like the last hour of page load or the last day or the last week, and that might be broken down intervals. So it might, if you say the last day, it might give you 24 intervals and then the stats for each hour. And so if we think about background jobs, this is where continuous aggregates comes into play. Basically, it's a view on your data, and the background jobs will kind of pull the data that's coming in from into your tables and then place it into this view, this continuous aggregate view. And then you can kind of read this on the fly without necessarily having to perform the aggregation. And if you're doing like page view aggregations, there might be like millions and millions of rows within the space of the hour that you're looking. So a continuous aggregate stops you from performing quite an expensive aggregation across all of those rows, and it does it in the background for you, and it kind of keeps it available to you at all times. So you can define continuous aggregates in the TypeScript driver. And the example here, it uses very similar syntax to the hypertable in that you define the aggregate, but you'll notice the first argument is actually a table. So you always define a continuous aggregate based off of a table. So the continuous aggregate is basically watching that table and collecting data points and providing you with an aggregate interface. I'll pass that over to you, Jonatas.
Yes, and also another cool thing is that the continuous aggregates are also hypertables. So they are also partitioned and they are also compressible. You can enable compression on them, and you can do another thing that's very cool, that's continuous aggregates on continuous aggregates. So generally you start like you have the raw data, then you have like, hey, I would like to compute or minute page views. And then from minute page views, you can compute hourly page views and then daily page views and monthly and so on. So these hierarchical continuous aggregates can help you to, let's say, instead of processing an infinite number of rows or like a non-defined number of rows, you have like a static number of rows because you know your subset. And that's where things really keep going in this good direction. So basically, continuous aggregates, they are materialized views. So we use the materialized views syntax behind the scenes from the Postgres. The thing is that materialized views, they are not allowed you to refresh it partially. So it's an operation that's all or nothing. You should run the full query. So in this case, as time is passing, we are using this idea of like you keep shifting the window, and we have an engine that we call materialization engine from this system that it tracks the watermark. So it knows where it stopped in the last processing of that continuous aggregates. So if you want to see like real-time data, you can even query the continuous aggregates, and then it knows the watermark and it unions the raw data from that point. And then it will just be like very fast because it's just like the smaller amount of data, and then just reuse the pre-processing. So this is the real-time continuous aggregates that we call, and you can also use some flag that you can turn it on or off as you want. Well, let's go for query. And this is I guess, the final part that we are going to see here, and then we will see it in action. So, Daniel, do you have anything that you want us to share here? This is just a very simple hourly example that goes and get like 1 day of data, filters by user agent.
Yeah, for those of you who are familiar with TypeORM, there's a new method that we've attached to the TypeORM repository called getTimeBucket. So this would not usually be available to people with a table. So this is one of the special methods that we've added. And then when you call it, it's going to edit some of the generated SQL and generate some more SQL for you and send to that and bucket some of the data. But if we have a look at what it's doing, it's calling a time bucket query on a page load model. And then for the range of a day, so the start and the end is 2 separate days. So this is basically going to give you an array of 24 objects with the data inside bucketed into 24 separate buckets.
That's great. Let's see it in action. So I will stop sharing my screen, and then you can start your side, Daniel.
Okay, let's do it. So we are the TypeScript shop today. So if you don't know TypeScript, you might be in the wrong place, but if you do, you're in the right place. Just to forward, the library is open source and available on GitHub, as Jonatas mentioned, so you can find it on timescaledb-ts. And as well as that, is available to you on NPM as well for free, so you can download it today. I won't go too much over the source code, but I do have an example repository, which we're going to kind of dive through a little bit for about 10 minutes. Okay, so here we are. I have some diff, but that's fine. So TypeRM, let's just briefly go over what it is and how to get started, and then we can see how we can integrate with TimescaleDB. So TypeRM itself is a NPM library. It's a TypeScript ORM for relational databases. The way that you get started is you do it through code. So you define your database schema via the TypeScript language, and you use what's called TypeScript decorators to add kind of syntactical sugar on these classes that get picked up via the migration process and then sent to the DB to become your schema. And then once you have migrated, which we're going to dive into migrations in a moment, you have access to the repository of each model that you define, and you can call methods on this repository. So in our example here, if I get rid of zoom window, you'll see we call .save with a JSON structure, and this is type safe for us as well. So this is one of the benefits and the typing in TypeORM, and that we just define our model once, and then we have rich language features and methods available to us, so we can start interacting with the DB. So that's enough about kind of how it works. We have a very basic repo here, but what I wanted to show you is how to kind of migrate into Postgres first, and then we're going to kind of move some things around in our code base and show you the additions that are needed to get working with Timescale. So I've Docker running locally, and I have nothing running at the moment, and I'm going to run for start just a bog standard Postgres instance. Let's go run that. Okay, so we have Postgres running. Let's check. Great. And there is instructions in this README which we'll share, but essentially you can run the npm run migrate command, and this is going to call TypeORM's CLI tool, and it's going to point us to the data source, which is a TypeORM specific thing, and it just basically tells you where the database is. If you want to log, we'll enable login just to make sure it's enabled for this demonstration, and let's run the migration. And you'll see that it picked up the model and generated the migration file for us, and it sent one table. It created the stock prices table and gave it the primary key as well. And we can go into pgadmin, double check that it's in there. Tables, okay, cool. And then the stock price, I'm not sure what that issue is, but we have the stock prices down there anyway. And so now we have a database that's migrated, and we have TypeORM that's connected to it. So let's have a look at some kind of time related data. So in this index file that we run, we connect to the DB, and then we insert basically 4 ticks from 2 separate symbols. One is on the first and 2 is on the first. Let me just double check the hours. Oh no, here we go. Yeah, so they're all on the first, but this is at 1 in the morning and 2 is at midnight, and they have different prices and volumes and stuff like that. And basically what this query is, this is using TypeORM in its raw form, and this isn't using any timescale specific stuff. So this could potentially be quite an expensive query if you're going to be running it at scale. But just to dissect it, what this query is doing is it's finding the sum of the price and the volume in an hour for each symbol. And we can run that. So clear, npm run start. You'll see that there's 2 hours in our data set. So we get 2 kind of bucket-like things, and then the sum of the price and the volume. Just to show you that works as well, we can change that to cover 2 hours now. And so we should see both of these increase So now you see that they've increased a little bit. This is kind of like how you would use time series data with type ORM without timescale. I'll just pause here because I feel like this is a very good point, maybe Jonatas, to discuss about some of the benefits. Like what could be wrong with kind of, issuing a query like this to your database without timescale.
Well, just a reminder for those not familiar with the volume of global finance market data, it's insane. Like you get hundreds of or thousands of events per second from the same symbol. So sometimes like people are trading the same symbol and you have like thousands of people like leaving a market or joining a market in the exact moment. And then in this scenario, what will happen is that you will be, let's say, needing to go to millions and millions of records. So let's say if you have millions of records in your index, even having the index will be very large. And then you also have to scan the index, and all these are very time consuming. And then because of the line 45 to 47, we have this like where clause that Timescale can detect this where clause and say, well, it looks like it's referring to the timestamp column that is the column that we are using as the time dimension. So it knows that these will be much less partitions, and then it will just slice and use the partitions that are necessary. So we can do a PSQL example later and show how it works. In the PSQL side, just like use and explain, analyze to show how it excludes the chunks if you want. Yeah.
We had a question about can we do on mobile? To answer that question, the library will work in Node.js. So if you're building a mobile application, maybe that's with React Native and a Node backend or something, then I don't see why you couldn't use this library somewhere in that stack. Thank you for clarifying that, Jonatas. Cool. So this is kind of how you would start to use time series data. And then as Jonatas pointed out, you would eventually get to a bottleneck with this because at the moment stock prices isn't a hypertable. There's nothing in the background that's making this efficient. And at query time, we're scanning essentially all those rows, which is going to be really expensive. So with that said and done, let's see how we can convert this example to use timescale. So the first thing I'm going to do is I'm going to stop my Docker container and delete it. TimescaledB is an extension of Postgres. So the API that I get when starting TimescaledB from Docker is going to be very similar. And I'm using the same credentials and port as well, so that most of my other environments can connect to that just fine. So let's start Timescale. Great. Let's just check Docker and see that that's been started. Okay, cool. Let's start with the first change that you need to do in order to integrate TypeORM with TimescaledB, and that is to import the hypertable directive from the library. So we can import this from TimescaledB TypeORM, and it's a hypertable. And so we're going to wrap this entity, and it's going to be let's go with all that. We don't need any of the options for now. It's going to be a hypertable. I think we can get rid of all of that too. There we go. And so now what this is going to do is it's going to add this specific statement into the SQL to specify that this is now going to be a hypertable. And to hook into the migrations with TimescaledB TypeORM, you also have to do one thing, and that's find your data source file, and you have to import the library at the top. And the reason why you have to do this is because we hook into the migrations and we kind of wrap some of the functions TypeORM exposes so that we can detect that something's a hypertable or not. This will do that for you. And then there's two other things that we need to do. One other thing that we need to do in this file, and that's to change our timestamp column to be a timescaledb specific timestamp. And so here I've declared it to be timestamp Z, which you can define, and that should work quite well, I believe, Jonatas, if you just declare timestamp Z. But we also just want to make it very explicit in the library, like this is the time column, and then all of the other aggregations get derived from that, because you might have another primary column in here as well. So we can do that, the time column, and we can just wrap it like that. So now we have a hypertable, and we know that we have a time column as well. Let me just check the div. Did prepare this cake earlier, so just double check in, and we'll check this one. One more thing, this line here. So again, to the point about importing at the top, we just have to import this library, which helps us reflect some of the imports. This is specified in the README as well, so you'll be able to find that. And okay, that looks good to me. So now what we can do is we can run our migrations again. But this time it's going to be migrating against timescaledb and not just a standard Postgres. So I'm also going to run debug so we can see some of our library's internal stuff that it generates. And we got a little bit more stuff in the console, but let's scroll right to the top. So first of all, this highlighted here, this is the exact same migration that was applied before when we was using PostgreSDB. So you could copy and paste this, and you could send it to a PostgreSDB instance, and it would populate with the same structures we had before. But then because we've imported the timescaledb library, you see that now it's started to add some timescale stuff for us, and we haven't had to define this. This is all coming from the import at the top of the file and the decorators that we define. So you don't have to know this, and you don't have to look at this as it is machine generated, but just for your reference, you'll see that it creates some extensions, make sure that they exist, which they should already be there if you're using the timescaledb Docker container. But then you'll see some funky stuff going on here. So you'll see that here, for example, we're doing an if else, and we're checking for the time column, and we're just making sure that it's the right format for timescaledb. So that's one of the benefits of using that timescale column. Time column from timescaledb is we're just going to make sure that it's the right format for you. And then the next kind of section of the generated query, you'll see that we're just doing some if-else statements, and we're checking if the table that you specified as a hypertable, if it is a hypertable or not. And if it is, we'll skip it. If it isn't, then somewhere down here, we'll actually add the statement in there to change that table from a normal table to a hypertable. And so that's it. So now we have a timescaledb instance migrated with some hypertables as well. So I think if I come into pgadmin now, I'm not sure what this is. It keeps on coming up. Maybe I just need to update. Oh, here we go. Great. So you'll see that we have all the timescale specifics in our database now. Tables. Triggers. Is there anything that we can see in here, Jonatas?
Yes, basically in this console we cannot see the let's say the catalog, but let's go to timescaledb information. That's also another schema, and then we have the hypertables.
Where about timescaledb?
Yeah,
Up here. It's not in
yeah, we have a timescaledb information. Yeah, without underscore. Yeah,
Ah.
and then you get hypertables, and just query the hypertables view. It's a view. Sorry, it's a views on
views.
last one.
Found it. Oh yes,
Yeah.
hypertables.
Yeah, so if you query it, you can see basically this. You can, yeah, probably you can see it as a query.
Like this, yeah.
Yeah, it's just a select star from this the name is timescaledb information dot hypertables.
Underscore information.
Underscore, yes, underscore information, and it's also missing a from.
Select star
from, yes,
and then it's dot hypertables, right?
Yes. Mm-hmm. Oh yeah, there is a typo in the hypertables. Yes, BLES.
Oh yes.
Now you can see information. It's missing an R. Information. Information.
Two typos.
Yeah, after O, you need an R.
Oh yeah. There we go.
Here we go.
Yeah.
Yeah.
English is a hard one.
Yeah, and like
from the
this
English
one
guy.
this one is will not show too much, but you can get then now the chunks just to get timescaledb information dot chunks, because then you see the metadata on like the partitions. In this case, we don't have data, so that's why it's empty. Let's create some data.
I'm going to take away the old and just bring back the new, the timescale. Okay. Now we can run this seed. Cool.
Okay, now we have the data. So yeah, now you see timestamp, the range start and range end. So it's a week.
This is the default
Okay.
7 days, right?
Yes.
Cool.
And then like if you create data in another week, it will just create another chunk, right? So and let's change the dates there just to create another chunk in another week as a good exercise. So just to change the month or something, or just the day, just to change. Oh yeah, good idea.
Okay, let's go.
Day two.
20. Is it
Yeah.
month or day? That's the
Yeah,
real
this is the
question.
day. So
Yeah. Okay.
yeah, now we have a new chunk. The thing is like now if you want to see how it works, you can just say explain, analyze, select count star from no, let's use the hyper table then. Like select count, open parents, put star. Yeah, from the page loads.
Hello?
Page loads, yes. And then you can run it. Maybe the problem is the previous line. Just remove the previous line
Am I
because
spelling analyze wrong? No.
try again, maybe
Oh,
tables.
stock
Oh,
prices.
we
There
have
we go.
stock price. This is the other example.
Right.
Yes, good point. So you can see here that we have, let's say, two partial aggregates, and this two partial aggregates is already parallelizing it, right? So this is what is cool when you start, let's say, so if your query goes and cover multiple chunks or all the data, you can still parallelize it, so you can operate under the partitions. And then if your data goes in several partial aggregates there in this case. So you can just put some where clause there now, Daniel, that says where time between, and then we can get timestamp between. And now just to copy and paste that timestamp that we got in the last insert we did. Yeah, this one is perfect.
Can we put that
Yeah.
as a string?
Yes, I guess you need to say single quotes instead of double quotes, and like 1 hour later or 1 minute later from this. Yeah. Yes. So now if you run it, we will see that it changes the conditions and it also filter out the other chunk. For some reason, it's not like showing all the details. Maybe this is the way that this tool is showing, but that's the point, right? You get this kind of chunk exclusion and it will be very fast. It will always maintain like a more reasonable, sizable tables that you can easily manage it.
Cool. Yeah, this is awesome to see. I haven't actually come in here and had a look at like what's going
Yeah.
on, but it is interesting to see. Like now you can see all these other
Also,
schemas, all
let's
these
go into
tables.
TimescaledB internal. Let's go and just check the internal because you can go to the tables now, and then you see that this is the real tables, Hyper 1 and Hyper 1 2. This is where your data really lives, so you can even query it if you want.
So you can query this kind of the same.
Yeah, it's just a query, select start from timescaledB internal underscore. It starts with the underscore timescaledB internal dot. I guess you can drag the table name there. It should work.
Really? Just
Oh
like
no,
this, you mean?
sorry. Yeah, I thought it would. We have some kind of shortcut for like fast query, some table.
This could be a really
Yeah.
old version of,
Yeah, maybe.
to be honest. Yeah. So it's the Hyper 1 chunk.
Yeah.
Okay.
So here you get exactly the data. So what it does behind the scenes is just to get the data for you in the subtables. The original stock prices is just like an abstract table. It doesn't exist. And then it just falls down into the real, let's say, partitions.
So does that mean that the data is duplicated in two places, or does that mean that like the
No,
real
no,
table
there is
just
only a
feeds?
single version. It's just a shortcut, a convenience that you call it from a single table name and you get it, right?
Cool. This is cool to see. Yes, with just those few lines of code, we added the hypertable and the type column to our models, these highlighted lines, and then we basically have everything we need connected so that when we write to that table, it's then going to write that data to one of these internal tables that we just kind of dived into. And the good thing about using TypeORM is that it's Postgres compliant, and so is timescaledb. So once you've kind of done a lot of these migration bits, which there's not many, you can then use the full feature set of TypeORM. So all of the querying, all of the inserting and the updating, and that's just going to reflect straight back into your hypertables, which is super neat. There's not really much to demo in terms of querying, but I will show you this get time bucket method, which is the one that we had just previously before we said could be quite dangerous at scale. You'll see that we give you this method that allows you to bucket these intervals better. Let's just dissect what this is doing. So this is asking us for a time range, and it's between an hour. So it's saying from midnight to 1 a.m. bucket in 1 hour timeframes and get the sum of the total volume for Apple. So that should give us, oh, we have a log sum. That doesn't help. Let me turn that off. This one. Oh. So you'll see from those 2 hours for the Apple ticker, we only got 2 entries for Apple. So they're both identical, the volume. But what we can do is we can add like another Apple in, or a couple of apples maybe. So in the hour. So we do 10 minutes in and 15 minutes in. And then let's give that another go. Now you start to see that on the zoomers, you'll see that on the first bucket that the volume has now been summed up for us. This is querying the hypertable and it's partitioning the time buckets for us without having to write some big SQL aggregation to do that for us. So that's kind of how you started with the library. It's pretty straightforward. You have to define the decorators and then run the migrations, and then you're good to go. So in terms of just a recap, the library is open source, available to you on the Timescale GitHub account. We're really looking for feedback as well. We have some issues and pull requests and some conversations in the Slack. So please, after this, if you're interested or you have any questions, then please file an issue or send a message on Slack. Jonatas, I'll pass over to you.
If anyone has any other questions, we can try to address here live. I think we don't get any questions until now, so we can just wrap up and just to remember that we have the TypeScript channel in the TimescaledB Slack. So join us and ask questions or interact with us, give us feedback. It will be all very, very welcome. And if you want to book some extra hour with me, office hours is the right way to go. If you want to know more about TimescaledB, or just to validate some specific thing about your use case, feel free to take a time on my calendar and let's talk. That's it, folks. So thank you very much for this call. I am very happy that we made it, and I hope that see more and more folks coding with TypeScript and Timescale now. Happy coding, folks. See you in the next time.
Happy coding. Bye, everyone.
Bye.